Good afternoon, students. Today we are going to discuss about your thermodynamic processes. So, what do you mean by thermodynamic process? When one thermodynamic system change its state, we called it as a thermodynamic process. Here we are going to discuss different types of thermodynamic process. One is your isobaric process, second one is your isochoric, third one is your isothermal process, fourth one is your isentropy, and fifth one is your polytropic process. So we are going to discuss these five processes in this lecture. Okay. So first one is your isobaric process. So in isobaric process, your pressure of the system remain constant throughout the processes. And second one is your isochoric process. In isochoric process, volume remain constant. And third one is your isothermal process. In isothermal process, temperature remain constant, entropy remain constant, and polytropic process, P V to the power n is equal to constant. Okay, so let us discuss about thermodynamics process. The definition says that the transformation of a thermodynamic system from one thermodynamic state to another is called as your thermodynamic process. So in a thermodynamics process, the system change its state from one to another. Okay, so let us discuss about in PV diagram. In pressure volume diagram, here suppose A is one thermodynamic state and B is another thermodynamic state. Here in A there is some pressure value and there is some volume value. In case of B, we also have some pressure, we also have some volume. So this change of pressure and volume from A to B is called as your thermodynamic process. Okay. First let us discuss isobaric process. If a system of gas undergoes a process in such a way that the pressure of the gas remains constant throughout the process, this is called as your isobaric process. So here iso means your same. Iso means same and bar is the unit of pressure. That's why this process is called as your isobaric process. Okay, so in isobaric process, the properties relationship means pressure, volume, temperature, and number of moles relationship. So pressure, volume, and temperature relationship is tell us that P1 V1 by T1 is equal to P2 V2 by T2. This comes from the ideal gas equation PV equal to nRT. PV equal to nRT, it comes from this. Okay. 1 minute. Oh. So as pressure is constant, then this equation reduced to V1 by T1 equal to V2 by T2. This is called as your properties relationship in case of a isobaric process. What is the work done in case of isobaric process? We know that for a closed system, the work done is derived by PdV integration. Okay. So here the pressure is remain constant. That's why it comes from the integration, and dV is your change in volume. Work done in case of a isobaric process is equal to P into V2 by V1. It is derived in kilojoule. Okay. Next one is your PV and TS diagram. For isobaric process, what is the PV and TS diagram? We will draw the PV and TS diagram here. Here in y-axis, we are taking P and pressure, and in x-axis we are taking volume. So as pressure is remain constant, so the PV diagram is like a straight line. Here it is state 1 and this is your state 2. So the system is transferred from state 1 to state 2, and as the pressure is remain constant, So the line is straight line, line is straight line. And in case of your TS diagram, temperature, entropy. T stand for your temperature and S stand for your entropy. In case of your TS diagram, this is like a curve. So from 1 to 2, the system travels from 1 to 2, and for TS diagram, this is like this curve. So how it comes like this? Now we know that for an isobaric process, your pressure is directly proportional to your temperature. As pressure increases, so temperature increases, and temperature entropy also the same relationship. That's why the graph is like this. Okay. Next one is your change in internal energy for an isobaric process. So change in internal energy means the internal energy of the system changes when the system travels from one state to another. So what is your change in internal energy? The delta U, it is stand for your change in internal energy. Internal energy symbol is your U. So change in internal energy equal to mCV. M is your mass of the gas, and CV stand for your specific heat. Okay, T2 is your final temperature and T1 is your initial temperature. So your change in internal energy is equal to mCV T2 minus T1. Next one is your heat transfer. So how much heat is transferred during this process? So we first know that Q is equal to mc delta T. From previous lecture, we know that Q is equal to mc delta T. Here, the amount of Q is your amount of heat transfer, m is the mass of the substance, C is your specific heat, and delta T is your change in temperature. So, from this equation, we derive this equation. So, Q is equal to m Cp, Cp your specific heat at constant pressure, and T2 is your final temperature, and T1 is your initial temperature. This formula is your heat transfer formula. Q is equal to mCp T2 minus T1. Next one is your isochoric process. We know that iso means same and choric stand for your volume. So this process is stand for your constant volume process. So definition says that in case of a isochoric process, the volume of the system remain constant. Likewise, we talk about your isobaric process. Here is also the properties relationship, or in case of a isochoric process. So properties relationship means P1 V1 by T1 is equal to P2 V2 by T2. This is your properties relationship. This equation comes from your ideal gas equation. So let us discuss why we write this. So we know that your PV equal to MRT. Okay, implies that PV divided by T is equal to M into R. Okay, so R is your universal gas constant and M is your mass of the substance. So as R is always constant, M is, we are taking M as a constant. So it comes from that from ideal gas equation, PV by T is equal to your constant. Is known as your P1 V1 by T1, and for final state it is called as your P2 V2 by T2. So we can also write that P1 V1 by T1 is equal to P2 V2 by T2. So for okay, so for as volume is constant in this process or isochoric process, volume remain constant. So here volume is omitted. So so the relationship, but the equation becomes P1 by T1 is equal to P2 by T2. P1 by T1 is equal to P2 by T2. Next, so work done in case of a isochoric process or constant volume process. As we know that here work done is derived by change in volume. So in case of a isochoric process, the volume remain constant. That's why the change in volume is also zero. That's why the work done in case of a isochoric process is known as your zero work done. So if the volume of the system remain constant, so we cannot derive any work from the system. Let us discuss about your PV and TS diagram in case of a isochoric process. So for a isochoric process, your pressure volume diagram, as pressure volume is remain constant, so the line of pressure and volume like this. This is state number 1, this is state number 2, and the graph is like this in case of your PV diagram. This is called as your PV diagram, or also known as your indicator diagram. If we come to the TS diagram or temperature entropy diagram, so for an isochoric process, the temperature entropy diagram is like this. So this is process 1, it's a state 1, and this is state 2. So it travels like this for a TS diagram. Next, the change in internal energy. For an isochoric process, the change in internal energy is equal to delta U equal to CV T2 minus T1. This is kilojoule per kg, as M is omitted here, so we are dividing by kg. So delta U, or change in internal energy, equal to specific heat at constant volume into final temperature minus initial temperature. This is change in internal energy. Next, heat transfer. Heat transfer is also equal to your change in internal energy. As we know that from first law, the amount of heat supplied to a system is equal to the change in internal energy plus work done. Means Q equal to delta U plus W. So we know that Q equal to delta U plus W. Before we know that, here in case of your isochoric process, your work done is equal to 0, means W is equal to 0. So here Q equal to delta U. This equation, this relationship comes from your first law of thermodynamics, that the amount of heat supplied to a system is equal to change in internal energy plus work done. So as we know that in case of your isochoric process, the work done is 0. So the amount of heat transfer is equal to change in internal energy in case of a isochoric process. So what is the equation? The Q equal to CV T2 minus T1, as it is shown here. Delta U equal to CV T2 minus T1. Okay. Next, your isothermal process. In isothermal, same cheese. Isothermal means your iso means your same. Therm word is comes from is related to your temperature. So in case of isothermal process, the temperature of the system remain constant throughout the process. Okay, so isothermal process definition says that in this process, the temperature of the system remain constant throughout the processes. Next, we are coming to properties relationship in case of isothermal process. So before we discuss that, we derive the equation P1 by V1, P1 V1 by T1 is equal to P2 V2 by T2. As here temperature remain constant, so this equation becomes P1 V1 is equal to P2 V2. This is shown there. P1 V1 is equal to P2 V2, and this is also we can say that PV is equal to your constant in case of a isothermal process. Okay, let us discuss about the work done in case of isothermal process. Okay, so okay, so we know that W is equal to integration V1 to V2 PdV. This is the work done for a closed system equal to your 1 minute. So otherwise you also know that PV is equal to constant for an isothermal process. Here implies P is equal to C divided by V. This thing we have to remember. So PV equal to constant for an isothermal process. So here we can derive P is equal to constant divided by V. This equation we have to put here. So here V1, V2, P we can put here C by V dV implies that constant coming out from the integration V1, V2, 1 by V dV. Okay. Constant coming out and the integration from V1 to V2 1 by V dV is the final. Again next implies 1 by V dV, we can the integration of 1 by V dV is your log V ln V V1 to V2. Okay. Okay. So ln log V V1 to V2 was drawn equal to, here constant is also there, implies W equal to log ln V2 minus ln V1. I'll write here. So 1 minute. W equal to implies ln V2 minus ln V1 implies W equal to ln V2 by V1. Here C is also there. C is also there, constant. We derived the constant from the previous relationship, and we know that PV equal to your constant. So we can also put PV in for case of your C. So the equation becomes, implies W equal to PV ln V2 by V1. W equal to PV ln V2 by V1. PV is also known as your MRT. So again the equation becomes W equal to nRT ln V2 divided by V1. So this is the work done, the formula of work done in case of your isothermal process. W equal to MRT ln V2 by V1. Okay. Same change in internal energy for in case of a isothermal process. So for a isothermal process, the change in internal energy delta U is equal to CV T2 minus T1. As the internal energy is directly proportional to temperature, or if you increase the temperature, then internal energy may get increases. So that's why we, how to find out how much internal energy we supply. Now if we minus the temperature of final temperature or initial temperature, and the that is means the change in internal energy. Okay, so in case of your isothermal process, what do you mean in isothermal process? The temperature remain constant, so your T2 minus T1 is equal to 0. As your temperature remain constant in case of isothermal process, so T2 minus T1 is equal to 0. Why? Now T1 is equal to T2 as the temperature is constant. So if T2 minus T1 is equal to 0, then your delta U becomes 0 in case of change in internal energy of a isothermal process. Okay. Next one is your heat transfer. From first law of thermodynamics, we know that Q equal to delta U plus W. But the amount of heat transfer is used to increase the internal energy of the system and doing some external work. Okay, so here the change in internal energy or the delta U is equal to 0. So the heat transfer in case of an isothermal process it directly utilized to do some work. So that's why heat transfer is equal is equal to your work done in case of a isothermal process. Okay. Okay. Thank you.